Hey guys, it's Malta here, and in today's video we're going to be continuing our investigation of limits by learning how to evaluate limits analytically. In our previous video, we introduced the concept of a limit along with how to find a limit graphically and numerically, but today we are going to take our understanding of limits one step further. So without any further ado, let's get into some examples. So to begin with, this section, just so you know, is 1.3. And I'm only going to be covering in this video the first half of 1.3, and then we're going to be getting into some of the more advanced topics of section 1.3 in the next video. So to begin with, the first problem we're going to be doing today is problem number 17. And problem 17 asks us the limit as x goes to 2 of 1 over x. And if we want to solve this problem, the one thing we have to do is we have to recognize that we are just going to have to replace our x variable here in the denominator with 2 because x is going to 2. So if we can replace x with 2, we have our answer for the limit as x goes to 2. So quite simply, the way to solve this problem is to replace the x here with 2, and you get an answer of 1/2. So obviously this is a very, very simple problem. And a couple of the others that we're going to do are actually going to be very similar in nature to that last one. So now in 19 we have the limit as x goes to 1 of x in the numerator over x squared plus 4. So once again, we're just going to replace our x variables in the numerator and denominator with 1. So we're going to get 1 over 1 squared plus 4, and this obviously should reduce down to 1 over 5. So that's good. Now one thing that I want to point out is in this problem, I use the proper notation when you're inputting a value in for a variable. And what you're supposed to do is you're always supposed to put parentheses around whatever value you're inputting into an expression or equation. So actually, in this problem 17, when I put the 2 in for x, there should actually have been parentheses around this, and then you would just have gotten an answer of 1/2. But that's just more of a technical thing. Some teachers I know might take off if you don't have that, but that shouldn't hopefully be too big of a problem. So now we have 21, and 21 is just asking for us to do the limit as x goes to 7 of 3x in our numerator over the square root of x plus 2 in our denominator. And once again, we're just going to do this substitution where x in this case is going to become 7. So we're going to put 7 in parentheses here in the numerator. The denominator, we're going to have then 7 plus 2. And thankfully these numbers are pretty easy to work out, so we get 21 over the square root of 9. That's not bad at all. That's 21 over 3, and that's equal to, of course, a value of 7. So as you can see, so far a lot of these have been pretty basic, pretty easy, and nothing has really been, too complex. Now, this question here is a little, more intricate just because there's a little more work they have to do, but none of it's too bad really until the last step. So we have f of x, which is just a function f of x, equals 5 minus x, and then you also are given the function g of x is equal to x cubed. So this is what we're working with, and this question's in 3 parts. So part A is asking us to find the limit as x goes to 1 of f of x, which shouldn't be that bad, because all we got to do is we have to say this is really the limit as x goes to 1 of 5 minus x, because f of x was 5 minus x, as they gave us. And then all we got to do is we have to do our replacement, where the x is going to become this 1, because that's what the limit's going to. So you get 5 minus 1, and that's going to give us, obviously, a value of 4. So that's our answer for part A. I'm going to scroll it down really quick here, just so you get some more room so you can see the whole problem. And part B is very similar to part A. We're going to be finding the limit this time x goes to 4 of g of x. So that's just like this, and it's just going to be set up in the exact same manner as the last one. So limit as x goes to 4, g of x, as stated from the problem, is x cubed, so we just put the x cubed here, and then we just put the 4 in, we cube it, pretty straightforward, and we end up with a value of 64. Now in part C here, this gets a bit more complicated, and not complicated in a calculus sort of sense, but this just requires you to remember some stuff from Algebra 2, which you may have forgotten. So it's the limit as x goes to 1, which is nice, of g of f of x. So we're just going to write that like this, and this is supposed to be in parentheses, so double parenthesis. And then what we have is, what we got to do is we got to figure out this limit as x goes to 1 of g of f of x. So first and foremost, what the g of f of x means is that the function value that we have for f of x, we're going to input into g of x. And so in f of x, we have a function that's 5 minus x. G of x is x cubed. So all that we're going to do is we're going to take the 5 minus x, and we're going to put that into the g of x. And so we're going to replace that x cubed, we're going to replace the x and x cubed with 5 minus x. That's just what g of f of x means. So what's going to happen is we're just going to end up with something that looks like this, and this should hopefully make some sense. So we're going to end up with 5 minus x cubed. So all that we did was g of x was x cubed. All that we did was we replaced that x with 5 minus x because that was our f of x function value. And now that we've set this up, now we can go on our way and actually solving the problem. So we're just going to do the same thing as we've done before. For all these other problems, we're going to put this 1 in here. We're going to close these parentheses off. We're going to cube this really quick, and we're going to end up with, if I could write a 3, that would be nice. We're going to end up with 4 here. This is going to be cubed, and this is going to result in a value of 64 once again. So really the tricky part of this question is being able to understand how the g of f of x works. And that's something that, if you did forget, I wouldn't be too surprised, because that's something that's an Algebra 2 topic. So wouldn't feel too bad if you don't recognize that. Although that will be on a lot of standardized tests, like the ACT and the SAT will ask a lot of those sorts of questions. So now we'll do 25, and 25 is really very similar to 23. It's the same setup. So we have 3 parts. We have f of x is 4 minus x squared, and then we get g of x is going to be square root x plus 1. So that's all pretty nice, pretty simple. And we have in part A, we have the limit as x goes to 1 of f of x. So once again, as we did previously, we're going to rewrite this. This is the limit as x goes to 1 of 4 minus x squared, as you can see. So we're just replacing that f of x function with its function value, which is 4 minus x squared. So now what we're going to do as we've always done. 4 minus, we're going to replace the x with 1. We're going to square that because we have to. We got 1 squared obviously is 1, so we get 4 minus 1. That gives us a grand value of 3. So that question, part A, is complete. Part B, we have something similar as we did last time. This time we're going to x goes to 3 of g of x. Alright, and then we just got to write this in again. So we have the limit as x goes to 3 of square root x plus 1. Going to replace that x value, that x variable in the square root, with 3, so we're going to get the square root of 3 plus 1. That's nice because that gives us a square root 4, which reduces down to a value of 2. So that's great. I'm going to scroll this up again just so we can fit part C in here. And part C is asking us this time the limit as x goes to 1 of g of f of x. So the exact same thing as we encountered in problem 23 in its part C. And so once again, we got to recognize that when you have g of f of x, we're going to take our f of x function value and we're going to put that into g of x. So we're going to replace the x variable in g of x with the f of x function value. So quite simply, that's just going to look like this. We're going to have the limit as x goes to 1 of the square root of, I'm going to extend that, square root of 4 minus x squared, because that's coming from the f of x value, plus 1. So that's great. Now we just got to actually carry out the limit. So we're going to have the square root here. We're going to have 4 minus then the 1. Keep that in parentheses, square it. And then parentheses on the outside as the problem dictated, then plus 1. So 4 minus 1 squared is obviously just going to end up giving us a value of 3. So we're going to end up right here with 3 plus 1. And 3 plus 1 is the square root of 4, which gives us a value of 2. So once again, that's just another one of those g of f of x. They're really not that bad. The only difference is you gotta be able to set it up so then you can actually evaluate the limit. But apart from that, it's pretty easy. So let me scroll this down again here. And there we go. Alright, so now that we've completed 25, let's do 27. 27 is asking us to find the limit as x goes to pi over 2 of the sine of x. And yeah. So what I'm going to say about this question before we get into it is, with this sort of question, do not fear trigonometry. You're going to treat it the exact same way as if there was no trigonometry and it was just normal numbers. So all we got to do is we just got to replace the x with pi over 2, because that's what we're going to, that the limit that we're wanting to find is as x goes to pi over 2. So we can simply replace this with pi over 2, and then using a unit circle or a calculator, you'll get that this is an answer of 1. So there we go. So that's pretty easy. The trig can sometimes be easier than just the regular numbers. So then 29, we have another trigonometry question. We have the limit as x goes to 1 of cosine pi of x all over 3. So if we quickly do this one, we'll get, we have cosine here of pi times 1 all over 3, which is nice because that reduces down to cosine of pi over 3, which is great because that, using a unit circle or your calculator, gives you a value of 1/2. And then you can put these in parentheses if you just want to make it easier if you're inputting into your calculator, but you don't necessarily have to. So then we got 31. 31 is another trigonometry one. Limit as x goes to 0 of secant of 2x. If you remember, secant is just 1 over cosine, but we're going to wait to make that, I guess, transition until one of the later steps. So what I'm actually going to do is I'm going to first say that this is the secant of 2 times 0. So that gives us secant 0 here. And then what we're going to do, so we can put this in parentheses again. So secant, and then in parentheses you have the 0. And so what this quite simply becomes is, this is the same thing as 1 over cosine of 0, just in case you're not familiar with secant, or you just want to use cosine because it's fundamentally easier. You will end up getting a value of 1 over 1, because cosine of 0 is 1, and that finally produces an answer of 1. So there you go, there's that. Now, we've got 2 more to do. We have 33, which is the limit as x goes to 5 pi over 6, which is great. Again, nice, simple numbers, which are always really good to have. So what we're going to do is just the same protocol as we have done before. So we're going to replace this x here in sine of x with 5 pi over 6 because that's what our limit is approaching. And we're going to do this, and we're going to end up getting here a result of 1/2, which you can do on your calculator or with a unit circle, which is what's really nice about the radians that they're giving us, is that they're really nice in the sense of they're good numbers that you can find pretty much anywhere. And then we have 35, which is our last question. We have the limit as x goes to 3 of the tangent of pi times x all over 4. So there we go. That's how the problem's set up. And quite simply, we're going to do the same thing as we've done before. Get the tangent of pi times 3, keep that in parentheses, over 4, like so. And then what's going to happen is we're just going to get the tangent of 3 pi over 4, which should hopefully sound familiar on your unit circle, and that'll give you a value of -1. So there we go. This is section 1.3.1. As you can see, the underlying theme in terms of solving these, problems is that you just got to be able to recognize that every single time we are doing direct substitution. We are directly taking what we want our limit, what we want to find our limit at, and then we're directly inputting that into the equation or expression that we're dealt. And so these are definitely, I would say, the simplest limits that we will encounter. In the next video with 1.3.2, we're going to see that it gets a little bit more complicated, and there's some, new fundamentals and rules that we're going to be getting some exposure to. But for now, thank you for watching the video. If you have any questions about any problems I didn't cover, be sure to comment those and I'll try and help you out. But yeah, in the meantime, stay tuned for a video on section 1.3.2. Once again, thank you for watching, and if you like the video, and if you want to subscribe, then subscribe.